Hello all, we are from Sanjivani College of Engineering. So today we are going to make a Matlab programming on the topic of root locus plot for a higher order system in Matlab along with my teammates Butsude Vedant, Chinde Gaurav, Sai Prasad Gosavi and Kale Tejas. So I am going to start the code for the root locus plotting for a higher order system. So here we are doing MATLAB program design. So firstly we have given a comment MATLAB program for root locus plot for a higher order system. For the clearing the window space, so and command window space. So we are using here CLC clear and close all. Okay. So again we are given a command like define the numerator and denominator of the transfer function. After that come example for the higher order system we are suggesting as a g of s equal to num by den num by den. So for the num equal to we are given a value like 1. So this is the numerator coefficients we can change as per our system. So for the denominator we are choosing the values like 1, 6, 11 and 6. These are the denominator coefficients we can change as per our system. So for the create the transfer function we have to take again for the system sys equal to transfer function tf and multiply with the number numerator and denominator. So again for the display of the transfer function we are taking a disk as a display and inside the bracket we are taking a transfer function. Bracket is completed. So again for the system display so we are selected as a disk and in bracket sys system. So next we will be explaining by the Vedant.
So hello everyone, I am Butsude Vedant. So further we are going to explain study our code. Now we are going to plot our root locus. Here we have created a new figure for that, and R locus is for basically for generate the root locus plot of the transfer function. The root locus shows how poles and the system moves as a system parameter. Typically gain varies, and here we have given title to our figure, and we have created grid on. So better visualization for better visualization. Now we have desired some time response parameters like zeta and omega n. Zeta for zeta is basically for set damping ratio, which determines the system oscillatory behavior, and omega n basically it is a desired natural frequency, which represent the speed of the system response. Here we display desired poles and S1 and S2. Here we have calculated poles which were S1 is equal to minus zeta into omega n plus Li into omega n into square root of 1 minus zeta square. It is the first desired pole, and this one is second desired pole. Thank you.
So hello student, I am Kale Tejas. So further score I have explained the display the desired poles, display the desired poles and display the poles S1 and S2, S1 and S2. So we have used the command to plot the desired poles on the root locus, and we have used the command hold on, then plot the real values of locus and imaginary value of locus, row and marker size and line width 2. We have taken a marker size is 8 and line width is 2. We have also do the same pole, second poles. Then we have add the legend root locus and desired pole. This is the title of our graph. Then we have give the command determine the gain for the desired closed loop poles. Then we have taken a constant k variables, and we have taken a poles S1 and S2. S1 and S2 we have represent the poles, then equals to R locus and SYS, and then display the chosen gain as resulting the closed loop poles. Then display the chosen gains in K, and display the K and display the closed loop for closed loop poles for closed system. Thank you.
Hello, I am Chindegoro. I am starting the remaining curtain in program. Display K. Display K print the value of the gain K. Display closed loop poles. Display the message before showing the closed loop poles. Display poles print the value closed loop poles. Closed loop transfer function. In closed loop transfer function, store the resulting closed loop transfer function. In time response simulation, create a time vector t from 0 to 10. This vector is used for plotting the system response over time. Step response plot. Plot the step response of simulation closed loop system. It is over the time response. And title in add a title to the step response plot. Grid. Last one is a grid on the better visualization of the response. Thank you.
Hello guys, I am Sai Prasad Goswami. Now further the remaining part and the output of the program explained by me, and now we will discuss this and we will compile this program. So now we have to just click on the run button. So now we can see the output here. So the axis is we will discuss for the axis is horizontal real axis represent the real parts of the poles. Then the vertical imaginary axis represent the imaginary part of the poles. Now the color lines, the blue, red and green curves shows the path locus of the poles of the closed loop system. Will take at the gain k varies from 0 to infinity. Then these curves are calculated from the open loop transfer function provided in the code. Then the crosses represent the open loop poles initial position of the system poles without feedback. In this plot, you can see that left hand side of the axis showing a stable system initially. Now we are going for the circles now. The circles which we can see in the our output plot represent the open loop zeros. If any system may or may not have open loop zeros depending on the transfer function defined in our code. We have to define in our code. Then the red circle represents desired poles. These are the user specified desired closed loop poles location based on the performance criteria such as the damping ratio and natural frequency tau and omega n. Their placement in the left half explain indicate the stable system design. Then the main thing which we have to means purpose of the plot is this root locus helps you us to visualize how varying k moves system poles toward or away from desired performance. The goal is to find a value of k that moves the pole close to the desired locations marked with the red circles. So this all the our today's videos contain, and thank you for your watching from my team.